Yes.
Oh, I love you.
All right, so Kaylee, what'd you get for the missing side? 10. Very good. How'd you do it?
26 squared minus 24.
Perfect. 26 squared minus 24 squared. Well, that's not doing that. Okay, so we did c squared minus a squared or b squared. Doesn't matter which one you call it. And you get 100. You take square root of 100. Just a second. And you get 10. So the missing side was 10. Then it said, Megan, the ratio of the what to the what?
Side to the side. The height.
The width to the height. So you need to put the width over the height. What's the width of the rectangle? 24. That's the diagonal. Let's call it a diagonal. The width is 24 and the height is, you just found it, it's 10. Is that a simplified answer ready to submit? No. 24 divided by 10. Math, enter. 12/5. So the answer to this problem, you can write it like this, 12:5. Or you can write it like this, 12/5. Those are two ways to write the answer. So that's what, now, next time I ask you for a ratio, all you do is divide them. Or put a colon in between them. All right, gather up your warm-ups. Before we get into today's lesson, I just want to make sure that we are okay on what we learned yesterday.
Yeah, we are.
Pythagorean theorem. What did we do yesterday? For the C. Converse. Pythagorean theorem, converse. So we learned how you can tell if a triangle is acute, right, or obtuse just by giving you the side lengths. This was actually the day before yesterday. So if I give you sides of 5, 8, and 12, in your calculator, figure out if that triangle is acute, obtuse, or right. Is it acute, obtuse, or right?
Don't we have to add two numbers to see if it adds?
Yes. So first you need to write Pythagorean theorem, and you need to write it backwards. You need to write Pythagorean theorem, and you need to write it backwards. Dimitri, which number is C? 12. Dimitri, what's 12 squared? That's a one that you memorize. 144. Megan, what's 5 squared plus 8 squared? 25 plus 64. What? Okay, 89. So that was step 1. You put c squared first. Remember, you have to write it backwards. And then you put a squared plus b squared. Then what do? No. No.
Wait,
No.
it wouldn't be a triangle because 144 is
No. It would be a triangle because it's 5 plus 8. 13. 13 is bigger than 12, so we're okay. It'll reach. It's not the squares, it's the
Why are we
sides.
square?
So what do we do now?
Do the subtract which one is bigger?
Yay, Torin! You put a greater than or a less than sign.
That's what it's called.
It's going to eat the bigger number. Which one's bigger?
144.
144 is much bigger. It's going to eat the 144. Is that acute, obtuse, or right?
Obtuse.
Greater than means obtuse. Very good. So we just concluded that this is an obtuse triangle. Julius, give me 3 sides of a triangle, and we'll figure out if it's acute, obtuse, or right. And don't look so annoyed while you're doing it.
It looks like you
Give me 3 numbers. Come on. Julius. 24. 17. What? 28. All right, guys. Acute, obtuse, or right. Go. 24, 17, 28. Yeah. You need a calculator. You can't square these in your head. 17 squared, 324. Is it 324?
28 squared is 784.
17 squared is 289. Never mind. Which one's C, Paige? Which one is C? No. You're supposed to tell me which number is C. Yep. So that one goes first. We're doing 28 squared, and then we're doing 17 plus 24 squared. What's 28 squared? 784. Matt, what's 17 squared plus 24 squared? 865.
So you gotta use a less than.
It's going to eat the bigger number. It's going to eat the 865. Is that a less than sign or a greater than sign? That is a less than sign. So what's the answer to our problem? Acute. Good job, Julius. We did an obtuse one, so we need an acute one next. Very good job. Okay.
That's why he was thinking.
Yeah, he was thinking so hard. All right, read that to yourself and think about what your answer is.
This triangle
Who can go to the board if this is right and isosceles and add markings to my naked triangle? Go, Torn. Go add markings that say it's right and it's isosceles. And y'all need to do it on your notes page. See, you have the same triangle on your notes page. Good job, Julius. Erase that second tick mark. Put it somewhere else. Oh, then the first tick mark. Yeah, erase that one. Can't be on the hypotenuse. Oh, put the eraser back in the eraser. Yeah. Yay! Very good. All right, do the same thing to your triangle. If it is right and it's isosceles, it gets a box and it gets tick marks. So mark your triangle. Today we are only talking about right isosceles triangles. One of my students one year called it a risosceles triangle. I thought that was a cute nickname. Get it right, isosceles, risosceles. Sounds like a rhinoceros. Okay. So what's this angle? 90. What's this angle?
45.
How'd you know that?
Because 290 equals 180 and 180 is the amount of degrees.
Oh. So there's 180 degrees in a triangle. And we've already used up 90. So how many is left? 90. And then this is isosceles. So we know those leftover angles have to be congruent, equal. So you take the 90 that's left over and you divide it by 2. And that's how you come up with, mark your picture, 45 and 45 degrees. So we are going to call this, like it says on the board, it says for yesterday, but we moved things back. We're going to call it a 45, 45, 90 triangle. And we are only talking about these kind of triangles today. So what we're going to learn is not going to work for any other triangle except for 45, 45, 90. Okay. So the triangle's right and isosceles, and its angle measures are always 45. 45, 90. Just put it in your notes. Put it in your notes. 45, 45, 90. Thank you for taking a break from your coloring too. Write that down. Okay. What pattern do you see? What in the heck is on my board?
Circles and stars
Mm-hmm.
and there's some 45s in there.
Is the star's always on the hypotenuse?
Oh, Brett said the star is always on the hypotenuse.
The circles are always on.
Well, the circles are everywhere, aren't they?
Yeah, but they're only like. No, they're on there.
So what's the pattern? Okay, so we've got a 45, 45, 90 triangle. Let's name the side and then the side and the hypotenuse. We've got circle, 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 star. What about this one? Circle, 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 star.
Oh, wait.
Circle, 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 star. Circle, 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 star.
Okay.
This does have to do with math, I
Across
promise.
From where the mark is where the circle and the star is. So
The hypotenuse?
That makes it like the longer, it's the bigger side.
Yeah, it's the bigger side.
So then that's the bigger angle.
Yes, 90 is the bigger angle. Very good. So the legs both have a circle on them, and the hypotenuse has a circle star. So that's going to mean something in a minute, I promise. Okay. I need your group to do A. You are finding the hypotenuse. You're finding the hypotenuse, this value, and you're leaving it as a simplified radical. I need your group and your group to do B. Do Pythagorean theorem and find the hypotenuse on triangle B. Your group and your group have C, and your group has D.
What?
So wait, C?
I don't know what I'm doing.
You have C.
Okay.
I want you to do Pythagorean theorem, and I want you to find the hypotenuse, Ashley. Find that for, you have triangle C.
Oh, wait.
A squared plus B squared. Yeah, you got it. That's because you have 50 stored in there for X. Or you have 10 in there. No. Yeah. Good. Very good. That's what you did. But not in your calculator. Your calculator can't square root X.
What's a radical?
Square root something. Yeah. No. No. What? Try to get B.
Wait,
I don't
That's
know.
3. What's that?
I'm guessing.
you said
That's
X.
3. 3 squared plus 2 squared.
You said X.
Well, this side.
No. I'm saying you put X squared in your calculator. You got 100. That means in your calculator X equals 10. You can't put X in your calculator because X is over there. So you told me it equals 2X squared. You took square root of that. You're right.
So much fun.
We'll talk about
Well,
that.
since it's an isosceles,
The sides are
the sides are
the
the
same.
same.
That's fine.
See, it'd be two sides squared.
When anyone in y'all group, your group has the answer, go right on the board. When anyone from y'all or y'all has the answer, go right on the board. When anyone has the answer, go right on the board. Anyone have it? Go write it. What'd you get?
3.
Oh, that's not a simplified radical.
Nobody told me that.
Wait, what is it?
Nobody told me that.
What is it? What'd you get? 7, no. What's 5 squared plus 5 squared? 50. What's the square root of 50? No.
Oh, wait,
No.
okay, so. Oh, it's 1.1.
Guys, simplified radical. You're giving me the decimal. I don't want the decimal. I want the simplified radical. What'd y'all get?
So I did do it right.
Yeah, go write it. Very awesome. Go write it.
You can wait.
Own it.
Okay, I got it.
Okay, go write it.
I'm not exactly sure.
I do not know if this is correct.
Perfect. Go sit down.
But
1 square root 2.
I did it. And then I was like, I'm just going to guess because I don't think I got this right. So then I gave up.
Close. You lost your 2.
What is it, 1x squared or 2x?
What's the square root of x squared? Do you know?
I have no idea.
Okay, we'll talk about it. This one is, it's that, but we'll talk about it. What'd y'all get? What'd y'all get? Just a second. Yes. What question? 3 squared plus 3 squared is 18. So you're factoring the 18? What numbers did you use? 2 and 9. So 2 is prime, and then 9 is 3 times 3. So what escapes? The pair. 3 escapes, and what's left in the radical? The 2 is left in the radical. Okay, now I want you to stare at all 4 of these triangles and make a conclusion. Kenneth, head up. Ashley, head up.
They all gonna have
They all have 2 of them.
A square root 2. Look at A. This is 5. What's this side?
5.
5. 5
2.
5 root 2. What's this one?
3.
3 root 2. 1
Root 2.
1 root 2. X
Extra.
root 2. Remember circle, 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 star? Circle, 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 star. 5, 5, 5 root 2. 3, 3, 3 root 2. 1, 1, 1 root 2. X, X.
Please tell me to find a song for this.
There's no song. I don't have a song. Okay? So, 45, 45, 90 triangles are special. They have a shortcut. Do you want to do what we did? 5 squared plus 5 squared is 50. Square root of 50 in factor tree. Do you want to do that every time? I don't want to do that every time. I want to memorize the shortcut. The shortcut is 5, 5, 5 root 2. If your legs are a whole number, then your hypotenuse is that whole number times root 2. Yes?
So if it's 11, it'd be 11 root 2?
Yeah, 11, 11, 11 root 2.
Okay.
Yes.
Just making sure.
So if we memorize this, we don't have to do the tree anymore?
You don't have to do the tree when you have a 45, 45, 90 triangle.
Okay.
Yes.
Just like this.
Kendall, yours was x squared plus x squared, which is 2x squared. And then you take the square root of that. That was a weird square root, sorry. The square root of 2 is just the square root of 2. The square root of x squared, the square root and the squared cancel and you get x, if you were wondering. But y'all don't have to ever do that by hand. All right, so write this down. Do you have a triangle? Yeah. X, x, x root 2. And then the rule is way down here at the bottom. Can y'all see this? X, x, x root 2. There we go. So that goes in the rule box. X, x, x root 2. And on the picture, just add the x's. The root 2 is already there.
What am I remembering?
X and x. And here you write x, x, x root 2. That's the rule.
Root 2.
This is called a special right triangle. It's special
So then,
because it has a cool trick. There's 2 types of special right triangles. The next one is 30, 60, 90. All right, now, if you're trying to find a hypotenuse, and this is in your notes, you're going to multiply by root 2. So 5, 5, 5 times root 2. If you're trying to find a leg, you have to go backwards. So if you're trying to find a leg, you're going to have to divide by root 2. So when you're looking for a hypotenuse, you multiply. Hypotenuse, you multiply. Leg, you divide. You already wrote it down?
yeah.
Hypotenuse, you multiply. Leg, you're dividing. So you're writing hypotenuse in the blank and leg, and then you're writing leg and then hypotenuse. Okay, flip your paper over. Flip. Go. You want to watch this?
Yeah.
Okay, we'll watch this. Let's watch at the end. It'll be our reward for finishing. We only have a few examples. Okay. So, this one is so easy. You don't even have to do Pythagorean theorem. You don't even touch your calculator. What is it, Torin?
Root 2.
9 root 2. Because this is 9 root 2. It's a shortcut. It's a pattern. You don't even have to compute anything. So A equals 9 root 2. Don't say it yet. Let everyone think. Paige.
2, 2.
Yeah. Well, what is K?
2.
2. Very good. 2 root 2. Paige grabbed whatever number was in front of square root 2, and that was the leg. So these are the easy ones.
Can they all be like that?
No,
See, they don't have
because they're not all like that in life. Well, that's because I didn't want you working ahead. So this is number 3. Add those in your picture. Remember, you can't do this if it's not 45, 45, 90. Is this one 45, 45, 90?
Yes.
Yeah, it is.
Yeah.
Yep. Now, I know y'all are getting scared because it's a fraction, but you shouldn't get scared. 5 halves, 5 halves, 5 halves,
5 halves root 2.
root 2. That's all there is to it. 5 halves, 5 halves, 5 halves, root 2. Don't even go to your calculator. Don't touch your calculator. You don't have to today until we get to a different example. So you simply take your leg and you multiply by root 2. You don't change your leg. It's still 5 halves. Another way to write this would be 5 root 2 over 2, if you were wondering. This goes in the numerator. Another way to write it would be 2.5 root 2, because 5 halves is 2.5. I'm just showing you different ways you might see it.
I
Okay.
would probably do the next one.
Yeah, it's prettier, huh? Omar, what'd you get? What's x? 2?
No.
What?
What? I don't know.
What?
1.
1, yeah. 1 root 2. Do you agree that when I put a number down, there's always a 1 in front of it? When I put a radical down, there's an imaginary 1 in front of it. So this is 1 root 2. X is 1. Because there's a 1 in front of that root 2. Sitting there. Invisible. Uh-oh. The answer is not 20 root 2, okay? Because 20 is the hypotenuse.
I don't know how to do it.
It's okay.
I tried.
Okay. So on the front of your notes, we said when you're looking for a hypotenuse, you multiply by root 2. When you're looking for a leg, you divide by root 2. You've got to go backwards. This one doesn't have a root 2 in it. You need to extract a root 2 out of it. Get a root 2 out of that 20. You need to divide by root 2 because you're going backwards. So everyone go to your calculator and do 20 divided by root 2. Good. 14.1. 20 divided by root 2. On this one, it does say we're allowed to round it to the nearest tenth. So you do put the decimal version, 14.1. But just to let you know, you probably think, well, why doesn't this one follow the pattern? I promise it actually does. This is 14.1, 14.1, 14.1 root 2. Everyone go to your calculator and put 14.1 root 2 and see if it almost equals 20. It should pretty much be 20. Is it pretty much 20?
Yeah.
19.9. Yeah, that's pretty much 20. So it does follow the pattern. It's just a decimal. 14.1, 14.1, 14.1 root 2. Add these to your picture because I know you don't have them. Are we looking for a hypotenuse or a leg? Hypotenuse. X root 2. X root 2.
What?
I'm just telling you, I'm saying the pattern.
I know, but it's
X root 2. 3 root 2. 3 root 2. 3 root 2.
square.
Root 2. No, you just follow the pattern. If this was 1, 1, it'd be 1 root 2. But it's 3 root 2, 3 root 2, 3 root 2, root 2.
Sounds like a cadence.
Yeah, sure. You take whatever the leg is, and you multiply it by root 2. Whatever the leg is. If it's a fraction, you throw the fraction in front of root 2. If it's another radical, you throw that radical in front of root 2. All I did was write them next to each other. This is not a final answer. Does anyone know what square root 2 times square root 2 is? Square root 4, which is, what's the square root of 4?
32.
2. Square root 2 times square root 2 is actually just 2. You can ask your calculator. Go ahead and ask it. Hey, calculator, what's square root 2 times square root 2? You should get 2. Yeah, but you didn't exit out. Nope. The square root of 2 times the square root of 2 is 2. You need to exit out of your radical or close the parenthesis. So, what's 3 times 2?
2. Oh, wait, sorry.
6.
Wrong
It's
thing. I was looking at the
6.
answer.
It's 6. So the final answer, BC, is 6. Just put 3 root 2 into your calculator. You'll get 6. As long as you close your parentheses and get out of your radicals. Okay, let me pause this. Okay, do your last example. Add these values to your notes. Oh, good. Whew, you could have already done it. Are you already done? Catherine, what's something we know about this figure? What would you do first? Yeah? What would you do first? No? Jeanette, what would you do first? Nasia, what would you do first? Really? Megan, what would you do first?
Divide 19 by 2. So you get both sides.
Okay, so you're assuming that this is a midpoint? Not a midpoint. Can't assume. Tori.
It's 45, 90, so then I would make the sides the same, so 19, and then where it...
Yeah, but 19 is this thing.
Oh, okay, so then...
Oh, wait.
Megan.
Subtract 7 from 19.
Yay! If that's 7, then that's 7. You can just bring it straight down. 7. If I have 19 and I've used up 7, how many do I have left? 19 minus 7. 12. Now everybody knows what to do. That's 12. This is 45, 45, 90. 12, 12, 12 root 2. 12, 12, 12 root 2. The answer is 12 root 2. The answer is 12 root 2.